A very good evening to all of you. Again, your trainer, instructor, mentor, Bharat this side. And today we are going to talk about another topic. And I believe the last topic for our networking basics. And after that, we are going to start with the defensive security side. So in terms of network, this will be our last topic. So today we are going to talk about one of the, again, important topics for us to understand how the world's entire network works, right? Like a person sitting in an office in Seattle, how he's communicating to his employee working in the same organization, but from a different geographical location back in India, right? So how does this all thing works? That's what we are going to talk about it up today over here. And in this particular part, we are going to discuss more and more things in terms of wide area network. So up till so far in this particular journey, we did talked about guys lots of things, some basics of network we did started with. We did talked about the hardwares, we did talked about the softwares, we did talked about the OSI model, TCP IP model, right? The types of cables. We even did talked about yesterday the switching and the routing part, how switches work, how routing works. And looking at the responses, this will be our final topic. And I want you all to again pay close attention to the topics which we are going to discuss for today. So let's get started, guys. In terms of networking basics, we are going to talk about our today's agenda, that is day 5, that is WAN, wide area network. So we are going to talk about some basics of WAN. Then we are going to talk about WAN transmission technologies, right? And then we are going to talk about some troubleshooting tools and how SDN came into the picture and changed this theory of transmission technology of WAN. That's what we are going to talk about in overview of SDN, right? So this is the agenda which is being planned for today. So we are going to discuss about this particular agenda. In this particular type of like WAN over here, we are going to talk about it in detail because all these communications which we do have, right, on our day-to-day basis, like you all sitting in a different geographical locations, so working from home to your office in a different geographical location, how these things are working, right? I hope all of you guys have thought about it, right? That how these things are working, isn't it? So WAN stands for wide area network. So it's a very large network. People generally do consider WAN as an internet. So I will clear it up over here once and for all. WAN is not a synonym to internet. Internet can be one of the type of WANs, but it is not. Internet is not WAN, right? So it's a large network of information that is not tied to one single location. That's what you can call it as WAN, right? So WAN basically can give us the facility of communicating, of sharing information, and much more things it can offer us between the devices around the world through a WAN provider, right? For all the organization who does have a international business presence, right? Who does have more than one geographical location, their business being located, and they want to communicate to their team members geographically, WAN is one of the most essential part for their everyday use, right? So as the internet is considered the largest WAN, so there are lots of different WANs, right? For example, InfosecTrain's one office is in India and another office of InfosecTrain is in UAE, Dubai, right? So we do have these two different offices. Now, how my Dubai office is going to connect with the India office, right? So this thing basically we can do is we can manage a WAN which can be basically provide a connectivity to our all the employees working in Dubai office to communicate with all the employees working in India office, right? So that is guys what we do call as WAN, right? So as described, a wide area of networks basically that used to form for telecoms, telecommunication networks that can connect multiple devices or the location across the globe. That can be one thing. WANs basically are again one of the most largest, or you can say even expensive forms of network available to date, right? One of the most expensive forms of computer networks available till date, right? These networks basically are established by service providers, right? So there are service provider who do basically provide these type of services with their like WAN to the businesses basically are being provided by the service providers. Like even a school or a government basically needs WAN. There are service provider who does provides this particular setup, and these customers of the service providers, they can use the network and store the data and communicate with other users no matter what the location they are coming from. As long as they have access to the established WAN, the access will be granted via various different ways. It can be lines, it can be VPNs, it can be links, it can be wireless networks, or it can be cellular or internet access networks, right? Service provider means internet service provider, right? So internet service provider will be the one who will be providing you the connectivity, right? ISP or connectivity service provider, you can say. So WAN basically are different than all the things which we have discussed earlier, like MAN or LAN, right? LANs basically are local area network. If there is a same physical location where all the employees want to communicate, that will be part of LAN. Now, if I want to connect my LAN in my Delhi office to the LAN in, let's say, Chicago in United States, how I'm going to do? There should be a WAN between which can connect the LAN of Delhi office to the LAN of Chicago's office, right? So that's where WAN will come into the picture. So purpose of WAN basically, if it does not exist, organizations will be isolated, right? To restricted areas and specific geographical regions, right? So that will be something which will be there if WANs were not there. So LAN can help you to work within the building, within the organization, but the growth to the outside area, let's say either different cities or even different countries, it's not possible with the help of LAN, right? Because the associated infrastructure will be more cost prohibitive for the organizations if they keep on using that same local network, right? And practically it will be not possible for any organization or any service provider to give you a LAN exceeding the cities, right? So as organizations basically grows and they do become international businesses, WAN will be allowing them to communicate between their branches, share the information and stay connected, right? Or let's say an employee who is traveling for work, WAN will be allowing them to access the information they need to do their job whenever they are traveling, right? So vans basically help the organization to share the information with their employees, with their customers, as well as their partner organizations, or if they do have any B2B clients or customers, anyone. Understood, guys? So that is what we do call as WAN. These are essential services, one of the essential services which we can offer to the public, and even the students who are part of any sort of, let's say, universities, right? They want to access the library databases or university research centers from a remote location. Of course they have to be part of that particular WAN. Even your bank has the same story, they do use WAN. So we are going to talk about bit more on WAN, right? But these are like few of the basic things which we should know about the WAN, right? That is the wide area network. You can say moreover, it is a type of computer network that spans over the entire large geographical area and connects different cities and even countries, right? So there are lots of communication links in a WAN, which is usually provided by your telecom partners, right? And these communication carriers who offers these sort of services are generally in forms of these. Like we will talk about it, that are either lease lines, either these are frames, frame relays, right? Either these are ATMs, either these are MPLS, or either these are VPNs, right? So multiple different transmission technologies you can say, or the communication links are being used by various different vendors. Understood? Let's do, before we do proceed towards those particular parts of the transmission technologies, we do talk about MPLS, lease lines and all. Let's do talk about guys WAN components, right? So WAN components guys basically are the part. So talking about WAN components, majorly in WAN, you will see four major components. The one will be end devices, the one will be communication link, the one will be the equipments of WAN, and the one will be basically service providers, right? So let me explain you all so that when we do talk about bit more in detail, you should know that when I am saying end devices, what is end device? When I'm saying WAN equipment, what is WAN equipment? So you should be basically aware about that particular part. So end devices, basically these are the devices at the end of the communication links, right? In WAN technology, we do also call them as edge. Let's say, let's say this is my network, right? This is one of my data center and the router through which the connectivity of this particular data center is, right? And this is basically one of my on-site deployments, right? Now the connectivity of this on-site deployment via this router. So this router will be one of my end devices, right? Because it will be on the edge of my deployment server's network, right? So end devices will be the part, these will be the devices at the end of your communication links. It can be basically a computer, server or router, right? Yes, of course, a mobile, a laptop. End devices that are responsible for generating and receiving the data. It can be routers, it can be servers, it can be computers. So that's what we do call it as a end device. Understood, team? Next we do have is communication links. So communication links, these are the physical connections, right? These are the physical connection that transmits the data between the devices, right? Now, if I do have one device over here and another device over here, right? So the link between to communicate the data, right? The entire link between to communicate the data is what we do call as communication link. Yes, it can be wired, it can be wireless, right? Communication links can be wired, it can be wireless, and it can use various technologies like lease lines, again frame relays, ATMs, MPLS, VPNs, anything. So the link which is connecting your one site to another site, that's what we do call as communication link. Make sense? Next we do have is WAN equipment. So WAN equipments, basically these will be including your devices like routers, switches, firewalls, these type of devices. It will be including all of your these type of devices like routers, switches, firewalls that are used to interconnect with each other, to interconnect the LANs and manage the flow of data between them, right? Of course, let's say there is device A and device B, right? Both of them are connected via one switch. Now this switch is connected to one of my routers. Now this router is connecting and another organization two devices from same switch, right? It is another switch. Now all this something similar to this particular part, this router can be connected to my WAN, right? It can be basically WAN or any other geographical location where entire of my different site is working. So WAN equipments basically will be your devices like routers, switches, firewalls that are used to interconnect the LANs and manage the flow of your data between those particular devices, right? So those are WAN equipments. Then there is guys service provider. Like someone did ask what is service provider. So these are the telecommunication carriers that provide the communication link. That means the connectivity from A to B that provides the communication links and the services that are required to build and operate a WAN, right? So services required to build and operate a WAN, service provider will be giving the communication link, service provider will be giving, right? And service provider will be offering various of these particular services like services to offer WAN, services to offer communication links. It will be offering it via multiple different things. Like I have already mentioned couple of times, lease lines are there, frame relays are there, right? There are ATMs, there are MPLS. We are going to talk about all of them in detail. We are going to understand all of them in detail. We do have VPNs, all of these. Like these are few of the examples how service provider provides you the services of WAN and creates a communication link between your site A to site B, right? So that is what we do call as communication links. Sorry, service provider. Now this part guys over here does not include all the options, right? Lease line, frame relays, ATMs, MPLS, VPN does not involve all the options. You do have SD-WAN also, right? We are going to talk about it later when we do talk about SDN. We are going to talk about it. So just be there. We are going to discuss it in detail, right? So that was your WAN components. Now WAN technologies, all these things which I was saying about, like the WAN technologies which we are going to discuss. So there will be lease lines, there will be frame relays, ATMs, MPLS, and packet switching. This is something which we already discussed. So anyone who is providing you the connectivity services, that can be basically one of the example of service providers. Now the very first thing is lease lines. This is my office over here. Let's say this is my office and this I am a telephone exchange, telecommunication company. So this is my telephone exchange, right? So what I asked my vendor is to give me a cable structure, leased line. Just like you lease an apartment, right? You lease an apartment, you lease an office, you lease an building. Same way you are leasing a particular line up over here, which will be having only yours and yours connectivity, none other connectivity will be there. So that's what we do call it as lease line, a cabled point to point connection that is dedicated communication link that you have leased from your service provider. So team, these particular lease lines are the part where we will be having a dedicated like service provider who will be giving services to a single customer, and there will be no contention of or there will be no connection of any other user with any other users over there. They will offer us high reliability, performance, and bandwidth, right? The normal internet which you are using, Like you can see some of us are facing issues. Why? Because that's a shared traffic, shared internet. So no one guarantees you about the latency, about the reliability, the performance and the bandwidth. But in leased line, you will be basically having all these particular things to a minimum level guaranteed, right? So that is what we do call it as leased lines. So these are available in various speeds ranging from minimum to minimum 64 kbps, right? They can have 64 kbps to several gbps, right? They can give you the speed of minimum to kbps to several gbps depending on your choice, and it can be used for various different things like for voice, for data, for video applications, right? So these can be used. So lease lines basically are used by typically large organizations that need to transmit their data in volumes, right? They need to transmit their data in high volumes and requires high level of privacy and security, right? So for them, lease lines are being used, and these are also used for real-time applications like video conferencing, online gaming, financial trading, right? You might have seen all those basically works in stock markets, the stock market exchange vendors, right? They do have a line basically which they have taken directly from the stock market central board, right? Like BSE in India, right? So a line has been purchased, and on that particular line, they do basically do their financial trading. Same way, anywhere where low latency, basically it's critical, lease lines will be used. If you are a small organization, I would say lease lines are good for us. We can basically maintain and use lease lines if we are a small organization. But if you are a big organization, you do have multiple offices and in multiple geographical location, this thing basically can be a chaos and it can be more expensive and practically sometimes even impossible as well, and it will be not economic at all, right? So that is basically one thing in terms of lease lines we do have. Next we do have is frame relay, guys. Now again, it's a type of WAN technology, right, that uses packet switching to transmit the data between a device. Let's say there is my regional office, there is my head office, there is some remote users and another regional office, right? So frame relay basically will be technology which will be using packet switching technique. Remember yesterday we did talked about packet switching. Entire of my data has been broken into the packets and it has been transmitted independently over the network, and like once it reached to the destination, it has been reassembled and then data has been used, right? So it's a cost effective alternative to your lease lines, right? These days we do not use it that much. Frame relays, you won't find it often, but these are cost effective alternatives to your lease lines, and it can allow multiple customers to share a single communication link, right? Multiple customers to share a single communication link to do the connectivity, right? So that is basically what we do call as frame relay, guys. Now again, it is available for variable bandwidths, like minimum to minimum you can get even 56 kbps. All of you guys, especially those who are from India and those who have used dial-up modems, have you have ever used dial-up modems? Like earlier we were having BSNL, MTNL sharing us those dial-up modems where we used to connect the call and then our internet connectivity used to get started. But yes, when we were kids, that's an example of frame relay. It offers various different bandwidths like 54 kbps, 56 kbps to 45, Mbps, right? 54 kbps to 45 Mbps, and can be used for various different purposes: voice, data, video applications, right? So they also use virtual circuits, they also use frame relay uses virtual circuits. Like in dial-up modem, when you used to basically make a call, what you were doing was you were making a call from your system to the service provider. And when a circuit basically was being given, then you were basically having the connection to the internet, right? Same way, it uses virtual circuits to establish the connection between the devices. These virtual circuits are the logical connections that are created by the service provider, and these can be basically temporary and permanent, right? So frame relay offers significant cost savings. These are basically the types of network which we were using earlier, and as customers we only have to pay for the bandwidth we have used, right? And we can increase and decrease our bandwidth requirement as it is basically being needed, right? So that is what we do call as frame relay. Before proceeding, any questions in any of these two parts? Lease lines, frame relays, both of them. Lease lines, you will find it often in your enterprise solutions, but relay, to be honest, I would say none. I have not seen it in past few years. So I would say none, but yes, sometimes it can be there. These things basically can be the part of frame relay. Now, just rephrasing the entire part in frame relay, what you used to do is, first of all, from your device, let's say you are in this regional office, you will make a connection to your head office, right? A connection one being established, you will be using packet switching. You will be sending your data into multiple packets over here, and that data will be reassembled up over here, and the person sitting in the head office will receive that particular data, right? So that's how it works. Like the one which we were having earlier with our Wi-Fi's, home Wi-Fi's, right? Dial-up modems. Those who are depending upon frame relays. Now, before starting with ATM, that is asynchronous transfer mode, I would like to answer one interesting question. With wireless technologies like 5G coming, do lease lines still work in wireless? So we are having lease line. Lease line is a connectivity which is wired. So we are not comparing it with wireless like 5Gs. So lease lines are the connectivities which are wired connectivities. Let's say I am a government entity and I need to connect one of my local cities department to the city, like the state's capital department, right? So I will be using lease lines up over there, not relying upon the wireless 5G, because that is something which is an open network, right? There will be another people's data being transferred. So I need high privacy, I need very low latency, and I need a dedicated connectivity bandwidth, right? So I will be of course using lease lines up over there, right? So now guys, let's do talk about ATMs, asynchronous transfer mode, right? So again, ATM, asynchronous transfer mode, is a WAN technology that uses cell switching, right? That uses cell switching to transmit the data between the devices, right? So it's a high speed technology. ATMs basically are having a high speed technology that offers a guaranteed bandwidth and QoS, that is quality of service capabilities, right? And this type of ATMs basically will be for the applications that will require very high performance, like video streaming, multimedias, high speed data transfer, right? These type of things ATMs will be suitable for. Understood? So these are basically Like when I do talk about QoS, quality of service capabilities, what does that mean? Let's say in my network, someone is basically watching a movie, right? And from another workstation, the calls are being received. So I can, in ATM, I can basically say that in case if you have to compromise with the bandwidth of the user watching movies, but calls should be basically having appropriate bandwidth all the time. It should be always real time. There should be no latency in my calls, right? So that is something which we can say as part of quality of service. If I want to, with the same existing service, if I want to have some sort of VIP treatment to one of my service, that's what we do call as quality of service, right? So ATMs basically offers a fixed bandwidth, right? Of let's say from 1.5 Mbps, I guess. Yeah, I do remember 1.5 Mbps to 622 Mbps, right? 622 Mbps from 1.5 to 622 Mbps, and it can be used for voice, data, and video applications, right? Again, ATM uses virtual circuits to establish the connection, right? And these connection between the devices one being established, it will be used by the sender and the receiver to transmit the data, right? And also guys, ATM offers multiple classes of services that prioritize the traffic based upon its importance. So that is guys what we do call as ATM, that is asynchronous transfer mode, ATM. So if you need more, like it's a mode for switching and transmitting the data efficiently and flexibly, and organizes it into forms of cells, right? And it is asynchronous. Why? Because asynchronous in sense because the reoccurrence of the cells depends on the required instantaneous byte rate or bit rate, sorry, right? So let's say there is an empty cell. It will not go by if a data is waiting to be transferred, right? For example, the reason I'm saying is asynchronous. I'm sending 5 types of data, out of which ATM will automatically check which data does have the high priority. It will pick up first and it will send that particular data first, irrespective of the data in the waiting, right? And when there is data in waiting, if there is a null cell, an empty cell which needs to be transferred, it will wait up till entire of your data transfer does takes place, right? So ATM does have a powerful flexibility that lies in its ability to basically provide high capacity, low latency for all the types of information, be it data, video, image, voice, and it is basically speed and distance independent protocol, right? So that is what we do call as ATMs. So cells from multiple or many different sources are multiplexed into single physical circuits, and there is a fixed length of these particular fields which are there in cells, and it includes all the routing information for whom it is to where it has to be sent, which ensures the faster processing speeds, right? Which helps you to basically get in your simple hardware circuits, right? So one of the greatest benefits of ATM is the ability to provide you support of wide range of conversations, right? While providing you transport independent from those particular services, right? So that is what we do call as ATM stream, right? Asynchronous transfer mode. Next one is MPLS. Someone was asking the full form of MPLS. So MPLS, a wide range of communication services while providing you the transport independence from those particular services, right? So MPLS basically it's your multi-protocol label switching, right? MPLS. Now consider it. Uh, MPLS basically it's a protocol that you can say works on layer 2.5. That is somewhere between your data link and before your network. This particular thing works, right? Now what it basically does is all in all, your MPLS is going to label, as the name suggests, it is going to label all the switches in between. So consider it in this way. Let me draw and explain you. This is my data center and this is one of my client sites, right? Now what I have done is I have asked my service provider to give me MPLS connectivity. Now I do not have to do anything. I have asked my service provider to give me MPLS connectivity from my data server to my client side, right? This is what I have asked them to do. Now I will be having one connectivity from my end, right? My ER, that is edge router to the MPLS, and my service provider will be providing a connectivity to the client's router, client's edge router, right? Known as again ES. So that is how it basically is working, right? MPLS, first of all, let me again theoretically complete. It is a WAN technology. First of all, understand it in this way. It is a WAN technology that uses labels to route the traffic. It does not uses IPs. It does not uses MAC. It uses labels to route your traffic between the devices. And of course, guys, it is flexible and scalable technology, which basically offers you QoS, quality of service capabilities again, and traffic engineering features as well, right? Now you can see this diagram, this green label, I wanted this green label to reach to this host B. Then I wanted this particular yellow label to reach to this host A. Now it will be going through all the intermediate switches where this is basically LSR means labeled switch router. It will be labeled, it will be sending the appropriate traffics to according to the labels. It will be sending to L2. Now L2 knows that if it's yellow, it will be sent to L3. If it is green, it will be sent to L4. And that's how it reaches to their destination. So labels, let's say I've given you all the labels and I do say that all the people who are having red labels come to right side, all the people who are having blue labels come to left side, right? And that's how basically if I have to pass any message to the red label, I do know that I am a switch or I am a router. I do know that if any message is for red red labels, I will be basically talking to the right side, and if there is any message to the left labels, I will be talking to the left side, right? So that is how basically we do have switching being done in multi-protocol labeling switch. Now why two? It can be basically depending on different infrastructure. It can be like the one is the incoming. There can be much more intermediary depending on your hops where your data needs to be reached, right? So there can be different LSRs, right? Label switch routers. These are different because these are labeled, right? Your ISP will be having this technology. So talking about this particular part again, now over here, my ISP is maintaining, my service provider is maintaining how I am getting connected to my client side from my data center, right? From my data center, how I am getting connected to my client side, my ISP is maintaining. Now it is totally private, right? It is totally private for me. It's not like that private means that no other traffic will be there. But yes, there will be other traffic also in this MPLS, which I'm taking from my vendor. There will be other traffic also, but my traffic will be totally separate because my traffic will be having a switch like a label. Let's say my traffic's label is Bharat. So any packet which is basically having a label Bharat, your MPLS now knows that if it is having the label of Bharat, it has to be transferred to this point. If it is having a different label, it might have to be transported to the different part, right? So MPLS works with labels, right? So these labels basically helps you to guide or tries your traffic to the source to the destination. So MPLS basically it's suitable for the applications that require high performance, right? For the applications that needs more security, like real-time videos, your VoIPs, and your mission critical data transfer if you do have anything, right? MPLS can be useful in that particular time, and it offers mixed bandwidths, right? Ranging from 1 Mbps to even 10 Gbps, right? And can be used for voice, data, and video applications. As mentioned, again mentioning one more time, MPLS uses labels to identify the traffic and route it through the network, right? And offers multiple classes of services, right? That prioritize your traffic based upon the importance. Let's say if I am having VoIP or critical mission critical data transfer, so I can say that prioritize my mission critical data transfer always as compared to real-time videos. If there is any buffering being going on in real-time videos, I am fine with that, but there should be no low bandwidth in terms of mission critical data transfer, right? So that sort of QoS I can have in my MPLS, multi-protocol label switching, right? So this is one of the major parts up over there. Sometimes you might have seen that people also do call as MPLS VPNs. And when it comes to the point VPNs, we always think that encrypted, right? MPLS are VPNs, but not the VPNs. That means the encrypted channel. These are virtual, yes. These are private, again, yes. These are network, again, yes. But they do not provide the connectivity like normal VPNs which we use in our devices, right? So that is, guys, what we do have as MPLS part, right? So we have talked about lease lines, we have talked about frame relays, we have talked about asynchronous transfer mode, we have talked about MPLS. Now to revise packet switching, let's do talk about it. So packet switching, again repeating for the users who have joined today for the very first time. Packet switching is a method, guys, that uses data transmission like we use for data transmission. Now in packet switching, a message, right? A packet, entire message or the data is broken into the several parts, right? Now you can see these numbers up over here. There was my entire data on source, which were having numbers 4321. So 4 and 1 is going as a small package over here, where 1 is going to this part, then it is reassembling to all of them are coming to various parts. 4 is coming up over here, 2 is going over here, 4 and 3 are going over here, and they are reaching to this destination. 2 is reaching to this destination. Now we do have 1, 2, 3, 4 all together back again and being arranged and reassembled up over here, right? So this is basically your packet switching actually. The diagram explains it very well. The data is basically broken into the several parts called as packets, and these are sended independently to the whatever optimum route for each packet is being decided, and it is reassembled at the destination, right? Each of these particular packet basically contains a piece of part that is called as payload. That payload does have the identifying headers that include the information of destination and reassembly information, right? Now you know that packets are basically sent in triplicates, right? Like one will be sent 3 times, two will be sending 3 times, three will be sending 3 times, four will be sent even 3 times. Why? Because it is used to check, like packets are being sent in triplicates to check the packet corruption, right? Every packet is verified in a process that basically compares and confirms at least two copy of them basically should match. If verification fails, let's say third copy is doing what? It is checking whether first and two are same. Number one and number two is same or not. If number one packet and number two packet is not same, the third will make a request, right, for the packets to be resent, and then again triple packets will be resent to the server, right? That is what we do call as packet switching. They are reassembling at the server because of the payload which is being sent with each packet. Each packet contains a payload information which contains the reassembly information as well. Like there is no anything which is hard and fast for your network troubleshooting. In terms of tools, if I do have to basically say, like there is nothing specific. Of course, if you are using any vendor-based products, like let's say if you are using the products from Palo Alto, so you do have their tools, you do have their options like the widgets to troubleshoot those particular tools. But in common, if I do talk about in common, if you have to basically go for any sort of network troubleshooting tools, which can be specific in general for irrespective of any sort of like vendor you are chosen, maybe Cisco, Palo Alto, or any of them. So there can be few of these particular tools which can help you. I would basically say, first of all, of course, your ping tool. You all do know what does ping does. It can help you to check the connectivity, right? Same, you can use traceroute or tracert, right? Traceroute or tracert can be used to see the entire route of your system to your destination. You can of course use IP config, right? IF config, these ones to see the configuration of your NIC network interface card. You do have commands like or tools like NSLOOKUP, dig, right? Which can be useful. Let me better way. Let me write them. So I mentioned you can have ping tool, you can have traceroute or tracert command, right? You can also have IF config, IP config, isn't it? So let me just write trace route, IP config for Windows, IF config for Linux. You do have ns lookup command, you do have dig command in Linux, right? You do have whois, which is one of the very nice tools in terms of network. If you want to go for port monitoring, connectivities, netstat is one of the best tools, right? To have a remote connectivity, you can go for tools like putty. You can use putty for that, right? You should know about tools like subnet calculator, IP calculator. These are going to help you to understand and see the depth of the networks and all. So these tools basically you can use especially for your network troubleshooting, right? Like one of the best tools in this I do like is netstat, right? It gives you the open port connectivity, right? And that open port connectivity, that too, basically you can use various different filters and it can help you to basically see those various different filters as well, right? So for example, if I do show you, I can use netstat, right? Hyphen an. You can see it is going to give me all of my active network connections on my various different addresses on my port numbers, right? Now I want to see which process is having those particular connections. I can use ANO, right? And ANO will also be giving me the process ID of that particular process which is having the connectivity. Now I can check and see whether the connectivity which it is having, it's a genuine process or not. I can even use A and B. The best part, it will tell me the process name which is using that particular connection, right? Like you can see Chrome is basically is connected to these ports, SharePoint is there. So I can see the process which is making a connection, right? Now I do know a PDF file should not make a connection. So I can look it accordingly and I can check and I can see whether there is any sort of wronggoing happening in my network or not, right? I can use ipconfig as a command to see all the IP configurations. I can go for ipconfig/all, which will display me all the details in detailed information of all of my NICs, be it virtual, be it physical. Then I can use ipconfig/display DNS command. It will show me the resolver cache of my DNS router, right? So all of these things I can use. Like what these things are, like my DNS basically maps the IP to the domain name, right? So this is my resolver cache, which my system basically always checks whenever you do request for any website. Ping command, I can use it to see whether the machine is alive or not by sending the ICMP packets, right? So these type of commands basically can be useful and these can basically help us to troubleshoot our network. Let's say I want to see the connectivity to that particular part is up or not, right? For example, I use tracert. right? Then I go for google.com. Now you will see it will count all the hops starting from my network up till Google, wherever I am, the hops are there in between. It is coming, it will go for all the hops and it will display me the information, right? For all the next adjacent routers available. Up till it reaches to the google.com, it will show the connectivity to maximum 30 ops. Now can you see it says traceroute complete? I am able to reach to this particular Google's IP from my end within 8 hops from my network, right? So that's all guys, you can use this to check and to connect to a particular part, right? So this is guys, various different tools can help us for various different parts. So that is all about your network troubleshooting tools. Now the last topic, that is SDN. SDN stands for software defined networking. Now, are we using MPLS? Are we using ATMs? Are we using frame relay, leased lines, packet switching? What exactly we are using? Yes, I've seen the organization who are using MPLS, of course, right? I've seen the organization who are using leased lines as well. But these days, entire scenario has been changed from the time SDN comes into the picture. Now, SDN stands for software defined networking, right? It is nothing but a network architecture that decouples the control and the data planes in the network, right? Like the source and the destination you can see, that is inside the data plane. The control, who will be having access to what, how the access will be done, will be the part of control plane, right? So in traditional network, the control of the network and the data plane were tightly integrated, right? Like how this packet will be transferred to this device from this source to this destination, it was tightly coupled and being checked, right? And the changes to network configuration has to require to changes to the control plane as well, right? That was in our traditional networking, but in SDN, the control plane is an abstracted site from the data plane, right? Data plane is the part where all of your source and destinations, your routing, networking will be there, right? So that's what we do call it as data plane. We do have this particular part of, you do call it as control plane. This is the part where network admin will be sitting and will be controlling the entire part, entire phase. That's what we do call as control plane, right? And then there is the upper one, which you can see the applications, that is the management plane. The control plane, the data plane. So first thing, the control plane basically refers to the network architecture component. That is basically going to define the traffic and the routing topology. This is where admin is going to sit and going to define the routing and the traffic routing entire part and the data topology, like network topology, how it is going to be. And based upon that same topology, it will be implied and applied in your data planes. So your data planes, like you can say this is a software. Uh, in an overall example, this is underlay, this is overlay. I am an admin, I am working on a software, I am defining the network architecture, and this entire network architecture topologies controls are being applied on the hardware devices. Let's say you are using Cisco, Juniper, or any other routers like from Palo Alto or anywhere, you are implementing them, these hardwares. Now, what you are doing is you are controlling all of these particular hardwares via a software defined network SDN, via a control plane, right? Where you are basically creating policies, you are creating various different topologies and network architecture, and via APIs you are basically sending it to your hardwares to be applied. SDN, so in control plane the abstracted data, the control plane basically it is an abstract which I have taken from data plane, right? Allowing the admins over here to manage the network to a centralized controller like ONOS, Open Daylight, these type of centralized controllers. It can basically manage the entire part. So generally we do have three things: controller, data plane, and application layer. So this is the controller in between, which is controlling via the software all of your data planes hardware, right? And there is applications. Applications, it can be basically my data centers. Another application can be my cloud computing. Another part can be my service providers or maybe my enterprise network, right? So these can be the applications of SDN. So coming back to the SDN, SDN basically it's going to help, like as an approach, it is going to help to us in such a way that we use software based controllers and APIs, right? Over here we do have software based controllers. In this part we do have software based controllers and APIs to basically communicate our underlying hardware over here, to communicate with our underlying hardware infrastructure and then directing that hardware infrastructure the entire traffic on the network, right? So it is SDN is basically different from your traditional network. Your traditional network uses dedicated hardware devices like router and switches. And to control the network traffic, you have to configure those router and switches. In SDN, what I'm doing is I can create and control a virtual network, or I can control a traditional hardware as well, that too via software, right? Via a software. Let's say, for example, there is a machine, right? Now, in order to basically access that machine, you do have a software, isn't it? So same way, there is a machine that is hardware over here. In order to access manage that hardware, you are having software over here. That's what we do have it as SDN, software defined networking, right? SDN will work over the internet. So that's how it will be useful, right? That's how SD-WAN came into the picture, and it is giving you the connectivity to control and manage your offsite networks as well, right? So network virtualization basically, that was one of the concepts which helped SDN a lot because it allows the organization to segment their virtual networks within the single physical networks, right? and to connect devices on those different physical networks to create even a single virtual network. Okay, so SDN software defined networking enables the newest way of controlling the routing of your data packets, and that too via a controlled centralized server. Now, why SDN is important? Of course, it will be helping you to increase the control with greater speed and flexibility. You can customize your entire network infrastructure. It will give you optimum level of security, of course, right? So these can be like few of the things, and the key difference between your traditional network and SDN is infrastructure basically. If I do say, SDN is a software based while your traditional networking is a hardware based, right? And because the control plane through which you will be controlling your entire network is a software based, SDN is more flexible than traditional networking because it allows the admins to control the network, to change the configuration settings, for provisioning more resources, right? Like for provisioning more resources, for increased network capacity, all from one centralized UI without the need of hardware to be configured, right? So as compared to your traditional networking, SDN offers even better security in many ways because software defined networks uses a centralized controller. Securing the controller, basically it's crucial to maintain to secure the network, right? If your controller gets hacked, yes, there might be the case your network might be down. So applications which you are seeing up over here, these application on the top, management plane. So these applications basically can communicate the resources request, right? Like a person sitting up over here, right? It can communicate the resource request information. I am a person, I want to send a file to this particular destination, and that file basically exists in application too. So it can be called up via like this, and it can be sent to this particular person. So that is basically the applications which basically communicates the resource request or the information about your network as a whole. Then there are controllers. The second one which you see, re-explaining one more time. Controllers are the one which uses the information from the applications to decide how to route your data packets. And then you do have your networking devices over here, which will be in your data planes, which will receive the information from the controllers about where to move that particular data, right? So that is basically your SDN. Now SDN brought one thing into the picture that is known as SD-WAN. So software defined wide area network. Using SDN, when I am going to create a wide area network, that is what I am going to call it as SD-WAN. It's a type of computer network that enables the bonding of multiple internet access resources like DSL, cable, another IP transports to provide the reliable high throughput data channels, right? That is what we do call as SD-WAN. Software based technology that delivers the virtualized resources to the entire wide area network connections over both. It can be your ordinary broadband as well, or it can be your private links like lease line as well, right? So concept of SDN was to control the hardware via software, right? Now applying the same concept of SDN to your WANs to control your wide area network via softwares. SD-WAN abstracts the traffic management and monitor from the network hardware and applies them to the individual applications, right? That is what we do call as SD-WANs. Like they can effectively route your traffic from your data centers to your branch offices and then the cloud, then the traditional WAN routers, right? SD-WANs can dynamically use multiple available connections to find the best delivery paths for the traffic across the entire network, eliminating the jitter or the dropped packets to deliver the optimal UI to your remote areas, right? So that is what SD-WAN can do. Like it can be my wireless, it can be my DSL, my cables, my lease line, which is connected to my data center, to my branch office. Now I can use SD-WAN to basically manage my virtual networks, to manage my another areas of my organization where I can control and manage the network via software, right? So that is guys what we do call it as SD-WAN.